Have you ever wondered how a jet airliner works? It's a marvel of modern engineering, a testament to human ingenuity and the culmination of relentless pursuit of knowledge. Imagine a giant bird made of metal, soaring high above the clouds, defying the laws of gravity. A jet airliner is a complex machine composed of numerous components, each serving a unique and vital role. From the robust airframe that forms the skeletal structure, the meticulously designed wings that provide lift, to the powerful engines that propel it forward. Not to forget the intricate systems that manage fuel, air, and even waste. Each element works in harmony, ensuring a safe and smooth journey across the skies. It's a fascinating world of aviation technology that's waiting to be explored. So are you ready to embark on this flight of knowledge? Fasten your seatbelts because we're about to take off. The backbone of any aircraft is its airframe. Let's delve into this. The airframe essentially is the skeleton of the aircraft. It's what gives an airplane its shape and supports its weight during flight, takeoff, and landing. Primarily composed of aluminum due to its strength-to-weight ratio, modern airframes also include composite materials that are both lightweight and strong. Now let's peek into the windows and doors. Windows in aircraft are small and round to withstand the pressure difference between the inside and outside of the aircraft. They are made of high-strength plastic that is resistant to impacts and temperature changes. The doors, on the other hand, are designed with safety as the priority. They are built to resist extreme forces and have complex locking mechanisms to ensure they stay closed during flight. Remember, every single component of an aircraft, from the airframe to the windows and doors, is meticulously designed for maximum efficiency and safety. Next up, we are flying to the wings of our jet airliner. Ever wondered why birds have wings? Well, aircraft do too. Just like birds, airplanes use wings and flight control surfaces to navigate the skies. The wings generate lift, allowing the plane to defy gravity. Now let's talk about the primary flight control surfaces. These include ailerons, flaps, and elevators. Each one plays a crucial role in maneuvering the aircraft. Ailerons, located on the outer rear edge of the wings, control roll, that is, the side-to-side tilting motion of the aircraft. Then we have the flaps. These are on the trailing edge of the wings and they extend or retract to increase lift and drag, allowing the plane to fly at slower speeds or descend without gaining speed. Finally, the elevators. Situated at the rear of the plane, they control pitch or the up and down movement of the aircraft's nose. So just like a bird, a plane uses its wings and flight control surfaces to soar, dive, and roll. Now we're ready to touch down. Let's explore the landing gear. Touching down smoothly requires more than just a skilled pilot. It's the landing gear that takes the brunt of a landing, and its design is a marvel of engineering. Built to withstand incredible forces, the landing gear is robust yet flexible. It absorbs the shock of touchdown while also providing necessary traction and braking power. Now let's shift gears and propel ourselves into the heart of the aircraft, the engines. These are the powerhouses that quite literally thrust the aircraft into the sky. Jet engines work on the principle of jet propulsion, sucking in air at the front, compressing it, combining it with fuel, and then igniting it. The resulting force propels the aircraft forward. Whether we're talking about a small twin-engine jet or a large four-engine airliner, the principles remain the same. It's all about harnessing power and controlling it with precision. With the engines powering us, let's turn to the auxiliary power unit. What keeps the lights on when the engines are off? Well, that would be the auxiliary power unit, or the APU. This is a small yet mighty engine often nestled at the tail of the aircraft. When the main engines are not running, the APU steps up to supply power for everything from air conditioning to lighting. It's an unsung hero, ensuring comfort and functionality even while we're on the ground. Now let's talk about fuel. Just like your car, an aircraft needs fuel to run. But instead of a simple gas tank, we have a complex fuel system. This system precisely manages the distribution of fuel to the engines and the APU. It's a delicate balance, controlling the flow of fuel to ensure optimal performance and efficiency. This intricate system is what keeps our aircraft soaring high in the sky. With fuel in our tanks, we're ready to dive into air management. How do we breathe at 35,000 feet? Well, the answer lies in the air management system of a jet airliner. This ingenious system is responsible for taking in the extremely cold, thin air outside the aircraft, pressurizing it, heating it, and then distributing it throughout the cabin to ensure a breathable environment for passengers and crew alike. Without this system, air travel at such high altitudes would simply be impossible. Moving on, we have the anti-ice systems. These systems are crucial for maintaining the aircraft's performance, especially in cold weather conditions. Ice can form on the wings, engines, and other parts of the aircraft, affecting its aerodynamics and potentially leading to dangerous situations. Anti-ice systems work to prevent this icing by either heating the surfaces at risk or by using special chemicals to hinder ice formation. So, we see that both the air management and anti-ice systems are paramount to the safety and comfort of air travel. Now let's shed some light on the electrical system. Powering a jet airliner is no small task. To keep the plane's many systems running smoothly, we rely on a robust electrical system. This network of wires, generators, and batteries is the lifeblood of the aircraft, powering everything from the cockpit instruments to the cabin lights. It's like the nervous system of the airliner, sending signals and power where it's needed. But electricity isn't the only power source on board. We also have hydraulic systems. These systems use fluid pressure to move the aircraft's control surfaces, such as the flaps and rudder. Think of it as the muscle of the aircraft, providing the power to change direction or alter speed. Together, the electrical and hydraulic systems ensure the aircraft operates at peak performance. They're like an amazing duo, working in harmony to keep the plane flying safely and efficiently. With power flowing, let's turn to the water and waste systems. Efficiency doesn't stop at fuel consumption. It extends to every aspect of a jet airliner, including the often overlooked water and waste systems. These systems are designed with the utmost efficiency in mind, ensuring the comfort of passengers while minimizing environmental impact. The water system in an aircraft is a marvel of engineering. It must provide clean, fresh water for drinking and washing, but also needs to be lightweight and compact. The system is pressurized to ensure a steady flow of water even at high altitudes. Furthermore, a heating system prevents the water from freezing in cold temperatures. The waste system, on the other hand, is designed to handle both solid and liquid waste. The waste is stored in secure tanks until the plane can be serviced on the ground. Again, the focus is on efficiency, with the system designed to be as lightweight and compact as possible. Next, we have the emergency systems. These are critical to ensuring the safety of everyone on board. From oxygen masks that drop down in case of a sudden drop in cabin pressure, to life rafts and life vests for water landings, every eventuality is prepared for. There's also the evacuation slides, which can be inflated in seconds, to allow passengers to exit the plane quickly and safely in an emergency. Lastly, let's take a look at the crew areas. These spaces are designed for functionality and comfort, providing the crew with a place to rest, eat, and prepare for their duties. The cockpit is a hub of technology, with state-of-the-art systems that allow pilots to monitor and control every aspect of the plane's flight. Meanwhile, the galley is equipped with ovens, refrigerators, and other essentials for preparing meals. The crew rest areas, typically located in the tail or above the passenger cabin in long-haul aircraft, offer a place for flight attendants and pilots to rest on long flights. Last but not least, let's illuminate the external lighting and antennas. These elements play vital roles in communication, navigation, and safety, and we'll delve into their functions in the next scene. Visibility and communication are vital in aviation. As we progress through our journey of understanding a jet airliner, let's shed some light on external lighting and antennas. External lighting on an aircraft is more than just about aesthetics. It's about safety and visibility. The red and green navigation lights, white anti-collision lights, and the landing lights are all critical elements. They guide pilots during night flying or in poor weather conditions, aiding in the prevention of collisions and ensuring safe takeoffs and landings. Now let's tune into antennas. The antennas on a jet airliner are the unsung heroes of communication and navigation. They transmit and receive radio waves, enabling pilots to communicate with air traffic control and other aircraft. These antennas also receive signals from navigation satellites, helping pilots chart their course accurately, even across vast and featureless oceans. And with that, we have completed our journey through a jet airliner. In our next scene, we'll wrap up with some closing thoughts. Stay tuned. From nose to tail, a jet airliner is a marvel of modern engineering. We've journeyed together through the intricate aspects of aviation technology, from the robust airframe, the meticulously designed windows and doors, to the wings that give the aircraft its lift. We've explored the flight control surfaces, the landing gear, and the heart of the airliner, the engines. We dive deep into the auxiliary power unit and how fuel powers this massive flying machine. We've understood the importance of air management and anti-ice systems in ensuring a safe flight. We've unraveled the complexities of the electrical and hydraulic systems, the essential water and waste management, and the crucial emergency systems. We've also peeked into the crew areas and illuminated our minds with knowledge about external lighting and antennas. All these elements work in unison to make every flight possible. Next time you board a flight, you'll have a newfound appreciation for the marvel that is a jet airliner. Until next time, keep your curiosity flying high.